Here is the exact question for this lesson. We have a non-inverting op-amp. The input signal Vi goes directly into the plus input. The minus input is not grounded directly. Instead, it sees a feedback divider made from RF and R1. First, we want the general relation between V output and V input. Then, in the example, Vi is 6 volts, R1 is 1 kilo ohm, RF is 2 kilo ohms, and the supply rails are plus and minus 24 volts. We will find the output voltage and the voltage gain step by step. The central idea is almost the same as before, but with one important change. In the inverting amplifier, the plus input was grounded, so the minus node became a virtual ground. Here the plus input is not ground, it is Vi. With negative feedback and an ideal op-amp in its linear region, the output moves until V minus becomes almost equal to V plus. Since V plus equals Vi, the minus node becomes almost equal to Vi. So this time it is not virtual ground, it is more like a virtual copy of the input voltage. Now look at the two resistors. The op-amp input current is 0, so the minus input does not steal current from the divider. That means RF and R1 behave like an ordinary voltage divider between V output and ground. The voltage at the middle node is the fraction R1 over R1 plus RF multiplied by V output. But that same middle node is V minus, and feedback makes it approximately equal to Vi. This is the whole trick. Now solve the formula slowly. We just said that Vi equals R1 over R1 plus RF multiplied by V output. To isolate V output, divide by that fraction. Dividing by R1 over R1 plus RF is the same as multiplying by R1 plus RF over R1. So V output equals R1 plus RF over R1 times V input. Then we split the fraction into 1 plus RF over R1. Therefore, the voltage gain is AV equals 1 plus RF over R1. Notice the sign, it is positive. This circuit does not invert the signal. Now plug in the example numbers. RF over R1 is 2 kilo ohms divided by 1 kilo ohm. The kilo ohm units cancel, so the ratio is 2. The gain is 1 plus 2, which is 3. If V input is 6 volts, V output is 3 times 6 volts. 3 times 6 is 18, so V output is 18 volts. As a quick check, the total divider resistance is 3 kilo ohms. 18 volts over 3 kilo ohms gives 6 milliamps. That current through R1, 1 kilo ohm, gives 6 volts at the minus node, matching the input. Before we accept the answer, check the supply rails. The example op-amp is powered from plus 24 volts and minus 24 volts. Our calculated output is plus 18 volts. 18 volts is inside the 24-volt limit, so the ideal answer can fit. If the same circuit only had plus and minus 12-volt rails, 18 volts would be too large and the output would clip. Here, with plus and minus 24 volts, the answer is safe. What does that mean for a sine wave? The frequency does not change. The output has the same phase as the input because the gain is positive. The amplitude becomes 3 times larger because the gain is 3. So when the input is positive, the output is also positive. When the input crosses 0, the output crosses 0 at the same time. This is why the circuit is called non-inverting. The non-inverting op-amp is read with 3 ideas. First, the input goes to the plus terminal. Second, feedback makes the minus terminal almost equal to that input, not necessarily 0. Third, the two feedback resistors form a voltage divider from output to ground. From those ideas, the formula follows naturally. V output equals 1 plus RF over R1 times V input. For this example, the gain is 3 and a 6-volt input gives an 18-volt output.